How do compound inequalities relate to calculus limits? Have you ever wondered how algebra and calculus connect? Today, we will uncover the relationship between compound inequalities and calculus limits. This connection is essential for understanding how functions behave as they approach specific values. First, let's break down what compound inequalities are. A compound inequality combines two or more inequalities using and or. For example, if we say x is greater than to and less than 5, we are defining a range for x. This means can only take values between 2 and 5. The and condition requires both parts to be true at the same time, while the or condition allows for at least one part to be true. Now, how does this tie into calculus? In calculus, we often talk about limits. A limit describes the value that a function approaches as the input gets closer to a specific point. Understanding how values behave near a point is key to grasping limits. When we define limits, we use inequalities to express how close function values are to the limit value. For instance, the formal definition of a limit involves the concept of epsilon and delta. Epsilon is a small positive number that represents how close we want the function value to be to the limit. Delta is another small positive number that shows how close the input must be to a specific point. This definition can be expressed with compound inequalities. We write it as the absolute value of x minus c is less than delta, and the absolute value of f of x minus l is less than epsilon. Here, the compound inequality with and ensures that both conditions must be satisfied at the same time. This means the input is close enough to c, and the function value is close enough to l. Solving these compound inequalities helps us find the delta that corresponds to a given epsilon, making the limit precise. This is where the connection between compound inequalities and limits becomes clear. For learners, understanding compound inequalities in algebra is a stepping stone to grasping limits in calculus. When students practice solving compound inequalities, they become familiar with working within ranges and intersections of values. This practice is directly applicable when dealing with limits. Limits requiring thinking about values within certain bounds, and compound inequalities provide the language to express these bounds clearly. Visualizing compound inequalities on a number line can also help learners see how inputs and outputs are restricted near the limit point. In essence, compound inequalities are fundamental in expressing the precise conditions involved in calculus limits. They allow us to describe the closeness of inputs and outputs in a clear way, making the concept of limits more accessible for learners transitioning from algebra to calculus.